the first time I've tried this. Okay, it's recording. Yay. Okay. I got to switch to a different set of slides. And how do I get this to go away? There we go. All right. Thank you for coming up here. I love seeing a really crowded room. This is awesome. This particular talk was originally created for Days of .NET. This was held in November here in town, actually out in St. Charles, and originally meant for developers. And in my job now, what I end up doing is doing a lot of work for software companies or other companies that have SQL Server databases but usually don't have a database administrator or don't have anybody that's strong in SQL Server. So these are some of the things that I have found over time. The really interesting thing is usually, especially with settings, I keep seeing the same things over and over and over and over. But so for that conference in November, I went ahead and put this together. Now, I'm sure some of the seasoned DBAs in the room probably will be like totally bored by the end of this, but hopefully everybody will learn at least something. Maybe for some of you, you will learn a whole lot. But either way, that's what the original intent of this session was for developers. Well, tonight, you probably have quite a few DBAs in the room. All right, who am I? He already went through all this. It's no longer SQL Server MVPs, it's now Data Platform MVPs. Microsoft changed it. So, good enough for all of that. So what we're going to talk about is 5 main areas that I see problems. First is configuration. Second is maintenance. Reusability, meaning I see too much reusability in SQL Server, especially from a developer mindset. I was a developer for about 5 years before I became a DBA, and your mindset is create functions, create reusable objects. Well, that doesn't always work quite as well in, for example, T-SQL. That always worked well as well. Index strategy or lack of index strategy, and also problems with queries, for example, searchability problems, meaning if a where clause is not searchable, we'll end up doing a scan of an index instead of a seed. Okay? So those are the areas that I see a lot of issues. All right, configuration. You can install SQL Server. If you hand somebody the DVD or give them the media, anybody can install it, right? Anybody can get it through the first few little things. They can click next, done, right? Anybody can do it. Pardon me? It loads on your C drive. It loads on your C drive, yes. All your databases go on your C drive. Yes. I always tell a story about a previous job I had where this other group didn't want me to help them with their SQL servers. They thought they could do it, and they had set up System Center, I think System Center Operations Manager, and then like a month later they came to me and they're like, everything just stopped. We don't understand. Well, they had provisioned data volumes and everything, but yet they ended up with all their databases on the C drive and program files. They all ended up there, and it completely filled up the hard drive and everything grinded to a halt. I recently just had an engagement, a really small engagement about 2 months ago, where a small company using hosted servers. They don't own their own servers, they're all hosted, and they didn't run out of drive space, but it was a 160 gigabyte database running on a really slow 7,500 RPM C drive. So all I had to do, I had a lot of recommendations on how they could make other changes to help their SQL Server, and once I moved the data files off the C drive, they were so happy. They're like, we're good. So they were so happy. But anyway, there's this nice wizard. It's really, really easy to install SQL Server, get it up and running, and you're successful for a while. You're happy for a while. It's easy, right? Well, it seems easy to me because I've been focusing on SQL Server for like 15 years. But really, to get started, it's relatively easy. So some of the things that you need to look at whenever you do install SQL Server are things like memory configuration, all right? Probably if you're a database administrator in here, you now understand you've got to configure min-max memory, especially max memory, especially if you have multiple instances on the SQL Server. One of the things you might want to look at is parallelism. And I'll have a demo in a few minutes that kind of shows what happens with that. Sometimes the advice out there is, oh, just change maximum, turn parallelism off, or turn, max degree of parallelism to 1. If you're working with SharePoint, that's what Microsoft tells you to do. So that's another area that needs to be tweaked, not necessarily turned off. And I'll explain what this is. For those of you that don't understand what parallelism is, I'll explain what it is during the demo and exactly how to make that change. So here's another thing. Microsoft comes up with new things every release, right? You get new features. For the most part, those things are turned off. So there's this really nice setting called ad hoc workloads, optimized for ad hoc workloads. It's been around, I think, since 2008 or 2008 R2, I'm not really sure. But it's really recommended that little setting be turned on, but it's off by default. So that's one of the recommendations that I make every single place I go. Turn this little thing on. It's a little bit of performance boost. And the other thing, database location, that's what we were just talking about. By default, your databases will end up in program files on your C drive. You don't want that happening. Unless it's just, on my laptop, just for me to do demos and do some development work, that's okay. But you don't want your, production servers that way. All right. I wish that this was taller, but it's not. So I got to sit down. So I apologize for that. All right. Let's go to SQL Server. I am going to be working with the AdventureWorks database. Not that it's a wonderful database, but there is data there. Okay, and we can do it. But what I did, a guy named Adam Mechanic was really tired of not being able to work with much data. And so he created a script. I call it the Big Adventure, but it will create some bigger tables from AdventureWorks data that you can play with. So I have run that. So I'll send the code and everything to Julie in the slides. So if you want to do this on your own, you can. All right, so the first thing I'm going to do is just change this setting here. spconfigure, for those of you who are not familiar with it, is basically a command where we can either see or change the settings on the server, most of the settings on the server. So if I just run this, I get a list of all these different settings. And if I don't change this option here to show advanced options, I just get a small handful of them. I don't know why it's like that, but it is. So I think 70 is probably how many we're supposed to have. But some of the settings you can't even change unless you turn that option on. So the thing I want to change is called max degree of parallelism, or max stop. And what this setting does is it tells the query engine that if this is a really substantial query, pretty substantial query, go ahead and take that big problem and break it down into smaller problems, smaller pieces, okay? If I have four cores, I can break that problem down into up to 4 cores, and then later bring that data back together. This is what parallelism is. Does that make sense? The bad thing is, and this is kind of a play on words, but yet it's really true. Sometimes when I say the query was parallelized, I end up saying the query was paralyzed. And sometimes it is, because there are so many things that seem to really mess up parallelism that sometimes the query is paralyzed and just sits there and it's blocking itself. Okay? That's what it looks like. So that's why you need to pay attention to the setting. By default, it's at 0. What does that mean? Does that mean that it's turned off? No, that means let the engine do whatever it feels like. If you've got 64 cores, we could break this down into 64 pieces. You've got 4 cores, break it down into 4. Okay, so in other words, at 0, I think it's up to a certain number of cores. I think it's 64. It'll break it down to. So, you know, that's nice. We want SQL Server to be able to do this, to break this big problem down. But sometimes, like I said, there's overkill. Some of these settings were created, especially with parallelism, like 15 years ago, when you first started having multiprocessor. Multiprocessor meant 2, right? 15 years ago. Now it means 32, or 16, or 64, or whatever. So there's a lot of diminishing returns. If I break my query down into 4 pieces, that might speed it up. But if I break it down into 32 pieces, maybe it's more effort to coordinate those threads and bring them back together, and it might even cause more problems. So that's one of the things that I always look at, especially if there's more than like 8 cores on the server. And then there's also hyper-threading, where it's a setting where you can make it look like there's double what you have. So there's a lot of craziness. So what I'm going to do here is just make sure that this is set back its default.
Okay.
Yes?
There's some Microsoft articles and things about how to calculate with the hyperthreading and all that. And do you go over that?
Yeah, so...
I thought they basically said not to go above 8.
Not to go above 8. So the question is, Julie's seen some articles, and how do you know what to set it? I look at the Newman nodes. If there's Newman nodes, then I look how many cores per NUMA, and that's usually 4. And that's so 4 or 8 is usually about what we set it. So that's what I look at. Usually, if you have a large number of processors, they're also using NUMA. Usually we end up, I think most of the time we end up usually 4 or 8, something like that. All right, so the first thing I'm going to do is I'm going to tell you, do not do this at home. Do not do this at work. I'm just going to go ahead and, on your production server, basically I'm clearing the memory out so that when I run this query, it's got to go to disk to get it. We'll see how long it runs. The other thing I want to do is take a look at the execution plan. So did I run this? Yeah, I did run that already. Okay, so what this is one of my big tables, and I'm just going to bring back one value so I don't spend a lot of time just returning the data. I just want to return one value, but we'll see how long it takes at the default, and we'll look at the execution plan. Again, the execution plan may be familiar to some of you, may be new to some of you. So how many of you use the execution plan on a day-to-day basis? About half? Maybe about 2/3. Okay. The execution plan tells me what's going on behind the scenes, how SQL Server figured out how to create the table. So this query took 5 seconds, and I believe there's like 30 million rows in this table. So if I look at the execution plan, I see these little circles. Do you see the little circles with lines? There's a lot of light up here. I wonder if it can be turned off up here. Then it would be easier to see. Wrong one. Yeah, that's better. There we go. So if you can see where there's those little lines, and you see the word parallelism. So this is telling me that SQL Server said this is a big enough query that we're going to go ahead and parallelize it and break it down into smaller pieces. And then eventually we have this little thing here where everything's gathered back together. I can also look at the properties, view properties, because for some reason my shortcut keys are not doing what I expect. If I hit F4, it just closes Management Studio. I'm not really sure why. So the actual number of rows was 31 million. And what SQL Server did is broke it down into 4 threads. And these are the number of rows in each thread. So one of the problems that can happen is if your data is really skewed,
sometimes you'll end up with one thread that's got a lot of data and another thread that's got a little tiny bit of data. That's usually when you get these blocking problems.
But I can see that SQL Server broke it down into 4 threads. This thread 0 is actually not dealing with the data. It's like a coordinating thread. And I have 4 procs on this server. I need to move along here. I'm going to take too long. Okay, so what ends up happening is a lot of times there'll be this, so database administrators use what's called weight stats. Anybody use weight stats in the room? Few people. Weight statistics tell you what things are weighted on. And you can look at that. And a lot of times you see this weight called CX packet. That's involved with parallelism. So you'll see that as a really high percentage. So people freak out and are like, what is that? Well, it can be, really the thing you need to do is probably do some query tuning. But one partial remedy is to change this maximum degree parallel setting to turn parallelism down. The problem is you'll see information, you'll see advice all the time that say, turn it off. So I had, so if it's SharePoint, you got to turn it off. If it's Microsoft Dynamics products, you turn it off. Like anything from Microsoft, you turn it off. Turn parallelism off. The way you turn parallelism off is you set this maximum degree of parallelism to 1. So in other words, the maximum degree that I can parallelize out a query is over 1 thread. So guess what? I'm not parallelizing at all. I'm turning it off. So I have one of my friends here we used to work together. We had this application we used to support. That's the only other application. Beverly knows what I'm talking about. We had to turn it on that particular app too. It took up like, I finally figured one day this one application took up 60% of our time. And that was another one. It was written so poorly, we had to set the max software on that one. But we couldn't change the queries. We couldn't change the indexes. So I'm going to go ahead and do this, and we'll see what happens. I'm going to clear out the buffers again. Again, don't do this on production. This is a great thing to do when you're doing a demo, but don't do it in real life. I'll run the same query again. And wait and wait. We're already past 5 seconds, so it's already taking longer. So okay, so it took 10 seconds. It took twice as long. If I look at the execution plan, remember those little circles with the lines, the little arrows? Those are gone now. So this is telling me that it just ran it as one big gigantic problem. It didn't break it down into the small pieces because I turned it off. You can also change the setting on a query by query basis as well with a query hint. I can't remember exactly the syntax, but I know you can do that. And if I look over at the properties, let's go to that's the very beginning. If I look at this, you can see all threads. I mean, it's not broken down into multiple threads. Okay, I got to get going on this demo. All right, so what if we turn parallelism down? I have 4 procs, and what have we said? You know, it's some overkill here. What if we turned it down a little and turned it to 3? What will happen? So let's just run that, see if it makes a difference. I don't really remember if it made a difference or not. There's another setting called cost threshold for parallelism that you can adjust to make it so that more trivial queries don't run in parallel, that is saved for more expensive queries. So this one took 5 seconds again, and if we look at the execution plan, so it took the same as if it was, you know, go ahead and go crazy. And if we look at, now we can see that it was over 3. And probably in this case, going from 4 to 3 didn't make much difference, but going from 32 to 4, for example, you know, would probably might make your query faster to not have to navigate 32. And like I said, a lot of the engine, a lot of how SQL works was SQL 7, you know, SQL 7, SQL 2000. Whenever they came up with certain values, certain things, the way things should be set, it was like a totally different world than what we live in now. Hopefully nobody's running SQL 7 or SQL 2000 in the room. You're running 2000? I feel sorry for you.
Then the software package, no upgrade.
Sorry for you. All right, I'm going to set my setting back and then go back to the slides. My problem whenever I was doing this for the .NET group is I actually had like 3 different demos in one. On that section, I like used the whole time just on that. All right, so the next, let's see, configuration, okay. The next thing is maintenance, and there's really, I've got 2 different ways to do maintenance up here. There's really 3 ways. 3 ways. First way is you really don't know what it is, and you don't do anything. I see that a lot, or maybe I see some sporadic, or maybe I see some really bad things. But first, I have a customer now that they're hosting, well, and this is a lot of big databases. In fact, their largest database is 4 terabytes. And their hosting company does their DBA stuff for them. And on every SQL Server, they put a job that shrinks all the transaction logs, shrink. Like some, they set it up there, and then on some of the servers, it was multiple times a day. And like, this is really not a good idea. But anyway, so that's one. You don't know anything about maintenance and you just ignore it, and you just figure your SQL Server is just going to come along and do fine, and one day your hard drive fills up. Or one day something gets corrupted, and you're like, oh, what do we do? I don't know. I guess we just lost all our data. So there's 2 ways, if you actually are doing maintenance, there's 2 ways you might do it. Or you might do a combination of these 2 ways. One is that you can have a maintenance wizard, another wizard. The maintenance wizard is fine, especially on smaller SQL servers. If you're getting into the hundreds of gigabytes, maybe you want to think about, something like the next option. It's easy. It's really easy to run that maintenance wizard and just fill in, you don't have to know what you're doing or know much about it to get a maintenance plan up. But then it's really meant for that, especially for places that don't have a DBA, that don't have a sort of person that's really, really good with SQL, or know a lot of SQL. But the other hand, there's some things in there that are bad, or not as flexible as they could be, that you're stuck with. One of the worst things in that maintenance wizard is the option to shrink all your databases. Okay? I don't know how many, at least the MVPs, have said, Microsoft, can't you get rid of that? Why is that there? People think that that's a normal thing to do. It's not. So you not knowing what you're doing can be bad. The maintenance wizard is meant, or it's fine if you use it, but make sure you understand it. And that the bad thing is, it's so easy to do, you don't have to understand it to use it. The other thing is it's not flexible. If you've got a lot of smaller databases, it's fine. Like for index maintenance, if you have larger databases, you don't want to, for indexing, re-indexing, you have to either choose, I want to re-index all my tables, or I want to reorg all my tables. And the real word is all. I have to do something to all of them, whether or not they need it. And if you've got a bunch of small databases, that's fine. But if you have large databases, you don't want to be doing that. So what ends up happening is it doesn't get done, when you start having problems. So there's no flexibility. But it's better than not doing anything. And I don't think it's bad. I think it's fine on a smaller database system. But once you start getting into hundreds of gigabytes, terabytes, you really need to go with the scripting route. The problem with the scripting route is you have to have some more knowledge. You've got to know what you're doing. But it's very flexible. What I can do is I can have a script that not only chooses which tables need to be re-indexed or reorged, but also they can look at the partition level if you're in a later version of, you have to be an enterprise edition, you can't even have partitions. But it can break, instead of just doing everything, it can just do what needs to be done. So, great, I don't have time to write all those scripts. What do I do? Well, here's a guy. I have a picture of him. I should put it on the slide. I have a picture of Ola and at a SQL Saturday in Miami. He was on vacation. He's from Sweden, I think, and he was on vacation in that area and did the SQL Server in Miami. I need to put that picture. But anyway, this guy wrote such wonderful scripts for maintenance and made them freely available that everybody loves them. And the SQL, people love Ola. So you still probably need to know what you're doing, but he's taken a lot of the hard work out of the equation as far as yeah.
I'll just say something. The maintenance wizard is very easy, and you can use it for doing your backups, to help you with your backups. So all of your system databases and your user databases should be getting backed up. If it's a test system, you still should be at least backing it up maybe once a week. Developers are doing something, and if they screwed up, they may want to go back and not lose everything. But the wizard's real good for doing that. And then Ola Halloran, where you go, it does give a description. It does tell you how you could tweak with the statements. So it gives you good information. And he does have backup, index, CDCC. He's got everything. He's got everything. And you could choose. You could say, do everything, and it downloads the jobs. It doesn't schedule them. And then you could pick and choose and modify to what you want.
Yeah, so that, hopefully they heard Ted, because that was a lot for me to repeat. But Julie's point was, again, you could do a hybrid approach. You could say, you know what, the maintenance wizard is really great for backups. It's not so great for index maintenance, so I'm going to just use Ola's solution for indexing and do a hybrid approach. That is a good option. And one of my customers recently was avoiding doing index maintenance because they had a hosted application, and whenever index is going on, their customers can't use the application because it's locking the tables when index maintenance is going on. And this is actually a web edition, believe it or not. I know. So I don't even think they make web edition anymore. But he said, once in a while we do index maintenance, but what we do is I have to put these files in place that shuts the website off, so my customers know that the website's off for a while. And then we run the maintenance, we kick off this job, and then we go back and put remove those files back, and then now the website's available again. So what I did here is I took Ola's job, and I'll show you those jobs in a minute. I took Ola's job, and I created a special one just for that database. And I added a step to put those files in place that say the website's down, and then run the index maintenance just on that one database, and then another step to take those files away. So then I have the other job does all the databases except that database. So it's super flexible. So let me show you. I think I hopefully have got those installed on here, but I didn't check that. I'll have to start that guy up.
I just in 2015 went through the rounds with Microsoft. And
I do have them.
They recommended using Ola scripts.
Yeah, everybody's using Ola scripts. So these are the jobs that it sets up. So actually everything except for the sys policy. One of them is a system job. Everything else, I believe, were things he set up. The thing I don't like is he's got these ones that have like command, that one might not be, I don't know. That one is. I would like something at the beginning of each job, like to say Ola or something, all of them, so I know, especially if I've got a system where I've got 20 or 30 other jobs, I would like these all together. But when you install them, I mean, you don't have to run them all. Just installing them doesn't make them run because you have to put your own schedule in. So let's see, let me look at this one. I don't remember if So he's got his command. You can go out on his website. So for example, if you wanted to not back up a particular database, you can change this command here. But on his website, he's got all the documentation. So if you want encrypted backups, if you're using that feature, he tells you how to change it for that to work. I helped the customer set that up last year. So super, super flexible. I think I've got a demo on actually what happens with indexes if they aren't maintained, but I think I'm just going to skip that because I think just showing you these, that's a demo, right? And you could play, I'll send Julie the code, you can play with that little sample there if you would like to see how changes to a table cause the index to become fragmented over time. Reusability. So as I mentioned, as a developer, I wanted to reuse all the time. I wanted to create all kinds of nice functions that I could just reuse. In T-SQL, that's not always a great idea. There's generally a performance penalty with functions, for example. Some procedures usually are not so bad, but functions can be really, really bad. I recently helped a customer out that it was a developer shop, and so they're using their same mindset to do T-SQL code, and they had this really complex code, and they had some scalar functions. Scalar functions mean I have a function in my select list, and I'm sending some data in. And what ends up happening, well, and what the other bad thing was, these functions underneath, they're actually calling other tables. If it's just doing a calculation, there's still a slight penalty, but it's not so bad. But if inside a function you're actually running a query, the bad thing is when you're trying to tune that or whatever, that's kind of hidden from you. When you look at the execution file, you can't see that. And it could be doing some really bad code. So what I ended up doing with that customer that day, the process that they wanted to help me tune was taking 3 minutes. So I took a look at it. He actually made a couple modifications to indexes, and I helped them clean up these functions because they were like functions. It was multi-levels of nesting as well. SQL Server can't come up with a good plan when you're doing multiple levels of views or functions. And those 2 little changes, cleaning up the functions took a little bit of work, but within an hour they were able to get it done. I was not even that long after I told them what was going on. So that 3 minutes was then down to 8 seconds. And a lot of the problem, well, there were 2 problems. There were a couple of index scans that were going on, plus they were calling the query inside the function was getting called with the same parameters like thousands of times. SQL was not smart enough to realize that, that was going on. So I can't remember what we did. I think we might have, I can't remember exactly what we did. In some cases, we might have created some temp tables, and others we might just have changed that code. We put in that common table expression. Whatever we did, it really made a difference. So you got to be careful with reusability. So avoid nested views. Avoid any scalar and multi-line indexes in text tables. So there's a type of index called an inline, not index, a type of view, not view either, function. Okay, if I could only talk, just to how cool it is. There's one type of function that does touch tables, but the only thing inside that function is a query. SQL Server turns that into a join. It's smart enough to figure out that if you have multiple statements in that function, or if you're using that function as if it's a scalar function, SQL Server is going to call that over and over and over and over, once for every row in the results. It's going to be really careful. So I'll show you an example. Well, the other thing too, you know, at the end of this session, Julie's going to give these two books with same book that I wrote. There's a lot of new functionality in SQL Server over the last 10 years that people don't know about. Isn't it crazy? Over 10 years. But sometimes there's a solution maybe in window functions that can help you instead of doing all these multi-levels of custom functions. So what I would like you to think about, you can do the inline table value functions, because what SQL Server does with that is turns it into a join. Stored procedures are great. You can't join a stored procedure in a table. That's the only thing. But you can run a stored procedure and see the results in a table, like a temp table. And temp tables are fine. So you just got to be careful. The other thing, too, is there's no one right answer. You know, you've got a lot of tools in your toolbox. Make sure you don't say, just because I have a hammer, everything's a nail. There's a lot of tools in your toolbox. And, you can say, I love common table expressions. I love them. But guess what? They aren't always the right answer. So sometimes I have to do something else. Maybe it's a function. Maybe it's a temp table. Whatever it is. It doesn't matter that I love common table expressions so much. So that's the thing. There's not one answer. And I have no idea how I'm doing on time. This is just too much fun to only have an hour. Actually, I started at what time? Like 10 after? Okay, because we had the introduction. Fine until 7:30. Okay, yeah, I'll be done by then. All right, so here's a function. I'm going to go ahead and create this function. And basically, this function lets you pass in a customer ID, and it returns a total. So this is a scalar function. It returns a value. It doesn't return a table. It returns just a scalar value. So I'll run that. And I also have this really cool function called get the first order. I'm hoping this is not a terribly long demo. I should have paid more attention. Where I pass in the customer ID and I find the very first order from that customer. So already that's really a bad, both of them are bad. And here's another one. What's the difference here? Get the first order amount. And here's a function where I'm passing in a customer ID and I'm passing in the current sales order ID, and I'm going to compare the current order to the customer's first order. And I'm calling all of these functions here. This is the type of thing that I was helping that customer with. This is the type of thing. So, all right, so if I run this, let me go ahead and drop the clean buffers again. Don't do this at work. And let's just see how long. Other thing, are these all sales order ID, sales order header? Yeah, I'm just looking. So the problem is I don't think I can really see it here because it's all the same table. But if I had inside those functions different tables, they would not show up. This is going to take a while to run. So what's happening is it's calling that function, which is calling three other functions, on and on and on. It's nesting. Oh, it took 6 seconds, which is not bad. So we have all the list of the orders and the difference from the current order from the first order that was ever created. It looks like all we did was do a clustered index scan and a sort. It doesn't look like it was that bad. I did a clustered index scan because there's no where clause. It doesn't really tell you the complexity of what's going on. If I had other tables in these functions that I was pulling from, they wouldn't show up in this execution plan at all. You can't see it. So when I'm doing query tuning, anytime I see function, it's an immediate red flag. So I could do, let's see, oh, there's my nested function. Okay, so here's another way to write the exact same thing. Whoops, let me do that again. I'm dropping the clean buffers so that I don't cheat by having the data in memory already. Close that out. Here's another way to write the exact same thing that all of that function stuff just did. You need my book to figure this out. I'm using the first value function. It's a windowing function. So here's another way to do it. I can't remember how long that one took. 6, okay. 1. All right, so when I look at the execution plan, it actually looks a little more complicated, but it really wasn't. It was actually much simpler because I could see everything that was going on, where previously I could only see one layer. I couldn't see all those layers. So that's just something to keep in mind. You know, reusability is really great for many things. T-SQL, you got to be careful. All right, index strategy or lack of index strategy. This is my favorite thing, absolute favorite thing, because how many of you, so several of you work at execution plans. Often there is a little green warning or a little green hint at the top that says, hey, here's an index that might help you. So, or there's a tool called the Database Tuning Advisor, which I was forced to use once because I had to document how to use it for a course when I was at Pragmatic Works. I'm like, really? Really? Do I have to touch this thing? So here's the thing. When I see that little green up there, I don't ignore it, but I don't blindly follow it either. I look at it as a suggestion. However, you know, a lot of places, they run that every single time they see one of those, they go ahead and run it. And then they end up calling somebody like me in, and I go in, and then there's a table with 35 indexes. And they're all overlapping, like they have one that's column A, column B. And then they have another one that's column A, column B, and column C. Then they have another one that's column A, and then they have another one that's column A with these and include. You know, on and on and on. All really the same thing. I had one situation where I was trying to help someone and they had so many indexes that SQL Server could not figure out a good plan for the query. Just by removing about half of the indexes, the query improved. So usually too many indexes, you think, oh, that's going to slow down your inserts, updates, and deletes because you got to maintain your indexes. But it also can slow down your select queries because SQL Server only has milliseconds to figure out a good plan for the query, right? And if there's 35 indexes for it to consider, it's going to stop. You know, it's going to come up with a plan, like the time is going to expire, and it's going to say, okay, and it hasn't even found the good index yet, okay? So that's another thing. So I love index tuning because it makes me look like I'm a miracle worker and magic. It makes me look magic, so I love it. So that's the problem. You know, I'm going to call it an index strategy or a lack of index strategy. So don't blindly follow the database, what is that called, DTA, Tuning Advisor. Don't blindly follow that. Or the index suggestions. You can look at it. Maybe index is a good idea. Maybe it's not. Maybe you need to tweak an existing index. Be careful with duplicate and overlapping indexes. There's people out on the web that have little queries that you can use to find these overlapping indexes. That's what I do. My first step number one, find all the overlapping indexes. Then I start looking for indexes that might be helpful. I had actually still an ongoing customer, started with them about a year and a half ago. The first thing we did, it was like a 28 gigabyte database. First thing we did was clean up the duplicate indexes and actually, I'm not sure if it changed the database size, but it changed the backup size. The compressed backup size was like 5 gigabytes, and just by cleaning up the indexes, it went to 4.5 gigabytes. So that seemed like about 10% of the database was just overlapping indexes. So that was devastating. Remove unneeded indexes. You may have indexes that are never ever going to be used, ever. Gotta be careful with that. Maybe there's a year-end process that needs it. Yeah, Julie, is that what you're saying?
No, have you found a query or something online with, because is your index being used, that gets cleared out every time you reboot or restart SQL Server.
Mm-hmm.
So have you found something that you can run periodically that stores the data in a table so you don't remove something that you need?
I haven't. So the question is, the statistics on whether an index has been used or not is cleared out every time you restart SQL Server. So it would be really simple to write a script to save that information, like on an hourly basis or something, or a daily basis. Super simple. So I haven't found anything, but I could write it. Not right this second, but I could write it. So the other thing that I look for when I'm doing index tuning, there's 3 big things. I just talked about one of them, was functions. Be careful with functions. When I'm doing index tunings, I look for key lookups and index scans, and I'm going to show you what a key lookup is in just a minute. Index scan means I've got a phone book. I'm going to read that entire phone book to find out what I'm looking for, instead of jumping to a particular page real quick. Index seek means I'm going to jump quickly to what I need to do. So let me go ahead and show you a little demo. I'm going to create a demo table so I don't mess up my freshly restored AdventureWorks. And I'm going to turn on one of my favorite tools, Statistics.io. What Statistics.io does is it lets me see how many pages were read from the table. So I can get kind of a clue on what's going on performance-wise. Remember how I said that you can't see anything that the functions are doing by looking at the execution plan? Same thing with Statistics.io. If there's something going on with a table that's inside a function, I can't see that with Statistics.io. So got to be careful there. And I'm going to turn the execution plans on. So here's a nice query. What was my demo? It's got a primary key on it. Okay, so the primary key is sales order ID and sales detail. Here's a query. So what this query is, it's looking for a particular product. There's no index on this product ID key, so it scanned the clustered index. Okay, that makes sense. I said, I'm surprised it didn't give me a little hint here, the little green hint. Surprised it didn't do that. But I said, you know what? This query would work much better if there was a non-clustered index on product ID. So I'm going to go ahead and add that. And then I'm going to, whoops, you know what? I didn't look at, let me drop this real quick. I forgot to look at the Statistics.io. Let me run that again. All right, so here's what you look for. This is really the most important number. The Statistics.io is logical reads. This is the number of pages that were actually in memory, touched in memory. Sometimes you'll see a number on physical reads, but that number will change. But logical reads should stay the same. If you make a change, it's a legitimate change. If you see a change here, it's a legitimate change. Okay, So that took, it took 0 seconds, but it took 1502 logical reads. That's really how big the table is. We'll create the non-clustered index. We'll run this guy again. Remember 1501?
Yeah.
Oh, wait a minute. Yeah, was that the number? 1502. Okay. Now, instead of a clustered index scan, I'm actually doing a seek on the non-clustered index. That's usually what I want to see. And if we take a look at the statistics IO, it only read 2 pages because instead of reading through the whole phone book, it was able to jump right to the right page. Okay? So that's really nice. So here's the thing. Notice that I've got my index only has product ID, but I also return the sales order ID. The reason for that is that the clustered index key is always part of a non-clustered index. You get that for free. So keep that in mind. But look what happens. So I sales order ID, and product ID is my index. So look what happens if I add another column. Now I've got 57 logical reads instead of 2. And actually it's the same number of rows, just 16 rows. The number of rows didn't change. So what's different? So what happened is because everything I needed was not in that index, it had to take some trips to the actual table. That's really expensive. And it takes 1 trip to the table for every row in the results. So every time it couldn't find, it couldn't find that order quantity, every row, go back to the regular table, back and forth. QLOOKUPs are very expensive. Okay, don't get rid of all of them. You can't have a perfect index for every query in your database, but this is one of the things that I always watch for. If it's a query that runs a lot, and I can make changes to the indexes, I'm going to try to take care of this. All right, here's a different, this one was 16 rows. Here's one that's a different product ID, but it's probably the most popular product in the whole database, 3,000 rows. And this time, 1502, does that number sound familiar? Because it scanned it. It scanned the table, and it gave me one of those green suggestions. So let me go ahead and look at that. So what it's telling me to do is create a new index on product ID and include sales order ID and order quantity. So anybody see a problem? There's 2 problems. Sales order ID is my clustered key, so I don't really need to add that. Anybody else have an idea of why this is, if I just run this, give it a name and run it, why that's a bad idea? It overlaps with the index I already have. So if I add this, now I've got one index with product ID. Now I have another index with product ID and an include of order quantity. So what I could do is drop my original, I could create this, get rid of sales order ID out of there. I could go ahead and create this, but I want to get rid of the other one. So I like to call it tweaking or changing it, and that's not really adding a new one. So that's what I would do. So again, I'm not just going to ignore this, but I am going to look at it in the context of what else is there. Or another thing, what if this had an includes like every single column in the database, in the table, every single column in the table, I might say, I'm not going to do this one. So I've got to look at each one, and really it's just experience. Over time you figure out what makes sense and what doesn't. All right, so I'm going to go ahead and drop my original index and create a new one with product ID and order quantity. And then go ahead and run this guy again. Again, I get back 3,000 rows. Now it's 10 logical reads instead of 1502. And now the execution plan is now an index seek. So now I've I fixed that. I've also fixed a problem called that can happen with parameter sniffing. You know, different when I have my data is skewed like that. So that's what I might do. So one thing that SQL Server does is all those little missing index things, even if you don't look at it, SQL Server saves those until you restart SQL Server. So there's a guy named Glenn Berry. If you haven't heard of him, write his name down. He's got a lot of queries using dynamic management views and objects and system views to help with SQL Server. And one of them that I like to run when I'm at a customer is this one, where it tells me it doesn't have that one in there. If I hadn't created that index, it would have shown up here. But it accumulates all those missing index hints for you. Even if you don't look at the execution plan, it's happening under the covers. So you can go and look at those. There's one for finding objects that are possibly not needed. So the problem with how he's got it is he's not looking at everything. He's looking at user seeks and scans and lookups are greater than updates. But you could use, tweak this to find missing index. This is coming up with nothing. Let me get rid of that. I always have to tweak this one. Still, it's only indexes that have been used. Haha, that's good to know. That needs tweaked. This is not right because sometimes indexes are there. If I haven't touched the table, I want to know that. So that's interesting to know. But anyway, Glenn has got a lot of great information on how to start like at the server level and go down to the database level on understanding what's going on with a SQL Server. How's my time? 7:07. Okay, what's left? I think this is the last one, Sargeability. So Sargeability means I've written my where clause so that it can perform an index seek instead of an index scan. So for example, if I include my column inside a function, even the built-in functions, most of the time that's going to cause a scan. Okay? So a lot of times that's done with dates. They want to find all the sales within a particular year, or use the year function, or something like that. Well, it'd be better if they said year, greater than or equal to January 1 and less than January 1 of the next year, something like that. So you got to be careful with that. So all are tricky things that you may not know about. For example, let's say, and I think I've got a good demo here. Let's say that you've got a column that you always put numeric data in it, but it's actually a character, like a varchar data type. Hopefully I'm doing this right. Yeah. So you get an implicit conversion. So you know that there's, where you guys are, you're always, this happened at Julie's, we had this whole discussion with your group. You know that you're always putting numeric information there. So you're writing a stored procedure and you go ahead and declare an integer variable and a parameter that's an integer. You compare that to an integer variable to a character column. What SQL Server has to do is convert those characters, even if they're all numbers. They're all numbers. It's not going to cause an error. The SQL Server's got to do a conversion on every single row. So what looks like a good where clause could actually be a very bad where clause. Okay, SQL Server's got to do that. And newer versions of SQL Server, you can see that in the execution plan. I think that might be starting with 2012. There's a little exclamation point. So be really careful. I actually did see some recently that some demo or some article I was reading where it's not always the case that a function on a column calls it. There were 2 or 3 functions that don't. I don't even remember which ones they are. So be careful that functions operating on columns. Be careful about implicit conversions, that little thing I just explained. Query on a secondary column. Okay, so think of the phone book. Secondary column meaning the secondary one of the index. Imagine that you meet someone at a party, and their name's Bob, and you want to find them in the phone book, but their first name's Bob, but you don't remember what the last name is. Okay, so your phone book is an index. It's a clustered index, and it's based on last name, first name. So if I only know the value of the second column, I've got to look for the entire index. If I knew the first, the value of the first column, I could jump so it works the same way. So be careful of that. And, rewrite your where clause if you can, query on the first column, and, if you can, get seeks. Let's take a look at, before I give this last demo, we got to be out of here at 7:30. Oh, okay. Yeah, so here's a public service announcement. If you're trying to leave, don't leave. So I want to give, at the end, a 5-minute spiel on Lisbon people where I work, and I have to give away a Past Summit 2015 recording, which is all the sessions from the Past Summit, a whole week long. I don't know how many sessions are in here. This is priceless. I mean, you can't buy it. It is priceless. You don't want to lose it. And I lost mine one year. I left them on an airplane on a trip to Fargo. I had the DVDs that year. I was on a trip to Fargo, left them next to me like a little ledge, and I was in Fargo for a SQL Saturday. And when I went and I called the airport, and the thing said, call the airline. Called the airline, it said, call the airport. I went back when I checked in, and when I was checking in, I asked, because Fargo is tiny, I asked, and they actually had my DVD. I was so happy. All right, so let's just look at some of these. What?
Instead of giving to one person, whatever you're trying to put online, everyone can access it.
Because that's violating copyright. That's pirating, that's piracy.
What about everyone who wants to see it can register so we can pass it around? So everyone can see it.
We can see them if your speaker doesn't show up, Julie can show them, because you can do that during the meeting. No, I can't. Yeah. Okay, so let's look at these. Let's look at these. So here's one where I know that the first name starts with an S. So I use the left function. If I look at the execution plan, I can see that it did use a non-clustered index, but it scanned it. Last name is the very first column of that index. I could do this. I could just rewrite this query and just say index seek. If I run these two together, well, actually, let me do that. Run both together. And I can see that the first one was logical reads of 109. The second one was just 14. So sometimes you can rewrite your where clause. But this is not so good. What if you didn't know the first letter? I met somebody at a party, and I know I don't remember that first letter, but I know it was M-I-T-H. I can't remember that first letter. I'm going to have to look through the whole phone book. So I'm back to an index scan. I can't remember what this one's going to do. When I was putting these together, there was an article I was looking at that said which things were sargeable, which things were not sargeable. And sargeable stands for searchable argument. That's what it stands for. And some of the things that it said were wrong when I actually tried them. This is an index scan. Not is an index scan. Here's one where I'm doing a search on the first name. Anybody have an idea what's going to happen? My index is last name, first name, middle name. Anybody idea have what I'm going to get? Scan. It's actually an index scan. And a missing index hint. Let me show you this one, and then that'll be it, and then we can start doing prizes. Insert. I've got a little table, and I'm just putting some junk in there. And I'm going to, I can't remember what I'm doing. I just have some numbers. I think these numbers get pretty high. And it is a character column, a varchar column, even though I'm putting numbers in there. Okay, so I created an index on that. So I have an integer, and I'm going to try to find, and I'm setting it to equal to 3, and then I'm going to, let's see, I'm losing track of where one thing starts and where one thing ends. Okay, so let's see. Let's run this piece. And unfortunately, this is way over here, logical reads 2. What did it do on the execution plan? So on the execution plan, see that little caution sign? That's telling me that there was an implicit conversion. You can see it, that yellow warning at the bottom talks about it. So what's happening is that even though that column contains only numeric data, SQL has to convert all those values to integers before it can compare them, okay? There's a priority list of what, kind of like a hierarchy of different data types, what gets converted into what. Numeric, character data gets converted into numeric when you compare it. That's why you get errors sometimes if there's... Yes. One of the directions. I can't remember which direction. You do. So the question was, do you get that same problem if you go from varchar to invarchar? And you do. One of the directions. One you don't, one you do. If I do, let's see. Let's look at this one. I have a character variable. If I run this one, it's still not going to be very many logical reads because it's a small table, and now it's an index seek. So, and that little exclamation point went away. So that's another one of those hidden things that a lot of people don't know about. If you can, what I always tell people is if you have a variable, make it exactly the same data type as the column. So here is my contact information.